So next problem, we will calculate the centroid of a T sections. Okay, not T section, it is a I section. Okay, so the question is find the centroid of figure shown in the figure. They given in the diagram. When you see the diagram, it is like a I section, but unsymmetrical I section, because both the flanges we have different. Web is okay. I read the dimensions. 80 into 10 they given the top flange. Web is given 10 into 40 mm, and bottom flange is given 25 into 24 mm. Here we have to calculate the centroid x bar and y bar for I section. So first you have to, when you see the diagram, you can understand here the given diagram is symmetrical about y axis. Why it is say symmetrical, that we have to understand. See, if you draw y axis, that is dotted line shown in the center, when you see this dotted line y axis, it passing all the elements from the center point. It meet, this axis meet all the centroid point of all three elements. That's why it's a symmetrical. So we consider it has reference y axis. So now we draw here, this diagram will divide it into three parts, 1 2 3. Okay, so I draw here reference line x and y. So now we have to solve this problem. By each element we have to calculate area x1 and y1, because here we have get three different elements. We will get x1, s2, s3, and y1, y2, y3, and similarly we get area a1, a2, and a3. Now we will start with solving first element. So see the position of element, that is same position and same thing we will draw only for element 1. So element I draw here, they given actually 25 mm is the width and height is given 25 mm. So when you see the expression, so for a rectangular section is always b by 2 or y bar is always h by 2. Now here a1, what is a1? The area is equal to 24 into 25, b is and h. So you get 600 mm square. 600 mm square is the area. Now we only calculate y1. What is y1? What is y1? y1 is 24 divided by 2. We are not calculating here x bar, because x bar directly will get the, at the end I will tell you how you get the x bar, because when you see the diagram, when you take y axis, so the larger element is 80 mm. If you take 80 and 80 divided by 2 will get the 40 mm. So the x bar directly you can get 40 mm. So now we need to calculate only y bar, because y bar distance we are not able to get. So now element 1 is finished. Now we have to calculate element 2. So element 2, so this is the element 2. When you see the element 2, it is actually at a height of 24 mm above, so where the element 1 is present. So I draw only element 2 here, so with the reference of x axis and y axis. So the area of this element is 40 into 10 mm, they given 400 mm square. Why do you have to add here? First 24 mm. Now for this centroid is y by h by 2. So h by 2 is nothing but 40 divided by 2 will get the 44 mm square. Similarly, we can calculate element 3. So position will be same as given the diagram. Now here the element 3 present from the y direction is 24 for first element, 40 is the second element. So it is above 64 mm. Okay, so now we have to calculate here area. Area is given 80 into 10 mm, so we'll get 1800 mm square, and y3 is 24 element 1, 40 mm the height of the second element. We calculating the centroidal distance for third element, that is h by 2, so we'll get the 69 mm. Now we have to calculate, because here they given three elements, so the general formula for this we have to calculate y bar is equal to a1 y1 plus a2 y2 plus a3 y3 divided by a1 plus a2 plus a3. So we'll get the y bar. So when you substitute all the value and calculate, you will get y bar is 44.44 mm. Similarly, when you calculating x bar here, x bar directly you can calculate, because it is symmetrical in y direction, so the value will get directly 80, which is the largest element, that is third element, that is 80 h b by 2. So b is 80 mm divided by 2 will get the 40 mm. This is your second type of problem.